All right, in our lesson 7.3, we're going to talk about completing the square. And you got to know, I know you're going to ask me why. Why do I need to complete the square? Well, why do you need to complete it? Because you need to be able to convert a quadratic into vertex form. Well, then why would I need to do that, you ask? Well, because it's easier to graph a parabola from vertex form. So the why do we need to do that? Well, we need to graph using vertex form because the vertex is so easy to pick out when it's in vertex form. So let me remind you what we've done. We've done standard form of the quadratic. We've done vertex form of the quadratic, right? Standard form is kind of helpful. It gives you the A, the vertical stretch and shrink, and it gives you the y-intercept, but you can't just look at the equation and pick out the vertex, so that's only so helpful. But vertex form, I can see the vertical stretch and shrink, I can see the vertex right here, I can see a lot of things that help me get to the graph more easily. So what we've covered so far is being able to convert vertex form into standard form. We've gone this direction, all right? What I'm going to show you today is how to go this direction, from standard form back to vertex form. All right, so it's going to be a skill called completing the square, which you can remember that name if you want. It doesn't really matter, but I'm going to show you how to do it. It's really not that difficult. Let's walk you through it. All right, so notice my trinomial, x squared here plus 6x minus 6. So here's what I'm going to do. I'm going to bring down my y equals, and I'm going to complete the square. So here's what's going to happen. I'm going to make my parentheses like that, right? And I'm going to take this term, I'm going to bring that x down. Instead of x squared, I'm going to bring x. Bring this plus sign straight down, and then I'm going to take this middle term and cut it in half. And I'm going to bring in the minus 6, and then I'm going to put a line over here, because here's what's going to happen. I changed this to x plus 3 squared, right? But if you FOIL x plus 3, here's what happens. We end up getting x squared plus 6x plus 9, right? Well, the x squared, that x squared is right here in my original. The 6x is right here in the original, but the plus 9 is not. So by writing it like this, I'm adding plus 9 to this equation somewhere in there. And so I need to balance that out to make this equation equivalent to the original. So I have to subtract something here. And what I subtract is what I would get if I FOILed what's in the parentheses. So in this case, I'm going to subtract 9. All right? And then all I have to do is clean this up. So it's y equals x plus 3 squared minus 15. And now it's in vertex form. Okay? Again, let me remind you, the reason we have to do this thing right here is we have to undo that 9 that we're adding. Okay? We have to undo it by subtracting. All right? That's what completing the square looks like. So let's try this again. Put it in vertex form, and today I'm going to want you to convert it back to standard form to check your answers. Okay? So let's look at this first one. So y equals, I'm going to put it in parentheses. I'm going to bring that minus 20 right here. Now let's break this down. So one way to think about this is to copy the x, copy the sign, and cut the number in half. So copy, copy, cut. Now, stop and think. If I FOILed out x minus 4, I would end up with x squared plus, or x squared minus 8x plus 16, right? How do I know that? Well, I know that because negative 4 squared gives me positive 16. So that 16 is what I need to take off the back. So I'm going to subtract 16. Now I clean this up. All right, there's what I believe my answer is. Now I'm going to check this. I'm going to check it. And the way to check this thing is to expand. Okay, expand it back out and see if it's true. So let's do that. Y equals x minus 4 times x minus 4 minus 36. Let's see if it comes back to the original equation. So when I FOIL this, I get x squared minus 8x plus 16 minus 36, x squared minus 8x minus 20. And sure enough, that is the original equation I had, so I did it correctly. Let's try the next one. All right, we're going to complete the square here. So I'm going to copy that variable, copy the sign, and cut the 10 in half, so it's 5. Bring that plus 7 down. Now let's stop and think. What do I need to subtract? Well, what is 5 squared? That's what I'm subtracting, minus 25. Now I clean it up. 7 minus 25 gives me negative 18. So there it is in vertex form. Now let's check this, see if we got it right. So let's expand. We would have x plus 5 times x plus 5 minus 18. All right, let's see if that takes us back to the original equation. So I square this, I FOIL these, x squared plus 10x plus 25 minus 18. Oops, sorry, that should be y equals x squared plus 10x plus 7. Yep, it worked out. It all came back to the original equation. That's what I wanted. All right, let's try one more. Same song, third verse, right? So let's copy this down. So I'm going to copy the variable, copy the sign, cut that middle term in half, and bring that minus 8 down. Now, what do I need to subtract off the end? Well, whatever this number is squared. So 2 squared is 4. That's what I need to subtract. So I give x plus 2 squared minus 12. There it is in vertex form. So let's check our answer, see if that worked. X plus 2 times x plus 2 minus 12. That gives me x squared plus 4x plus 4 minus 12. Clean up those last two terms, so I have y equals x squared plus 4x minus 8. And that is my original equation, so I did it correctly. All right, so this process again is called completing the square. And again, why do we do it? Well, it helps us convert from standard form back to vertex form to graph quadratics more easily. Hope that makes some sense. Ask questions if you need to, okay?